biological laser, an event cloaked in time, high-definition 3D television. This video highlights these and other exciting research findings that characterize the year in optics. This year, improving the quality of high-speed optical data remained a key area of research. Techniques that use optical pulses extending from the picosecond to the attosecond were also an important adjunct to nanoscale science. An Italian team reported on a new form of 3D lithography that freezes nanoliquid drops of nearly flawless optical quality. A team at Imperial College in London extended the idea of cloaking objects in space to hiding events in space-time, while US researchers explored how to use single-atom thick graphene to bend light backwards. These new concepts are coming from clever mathematical views of space-time in general relativity, where the desired optical path is determined by coordinate transformations. Light has often been used to probe biological structures, but never before has a single cell been made into a laser. Harvard researchers developed what may be the world's first biological laser by genetically programming cells to produce light. Potential applications include intracellular sensing and photomedicine. At the quantum level, the act of measurement can actually influence what one is measuring. European researchers have developed a new type of measurement based on the interaction of photons that challenges us to rethink the so-called Heisenberg limit. Other exciting work is being done in quantum information theory and the detection of low light levels. If only light could be controlled as easily as an automobile. And indeed, we now seem to be learning how to construct ordered index of refraction modulated structures that allow us to control the propagation of light. Initially, researchers were simply interested in fabrications. Now they are exploring limitations in the structures. The first generation of imaging and spectroscopy systems that use terahertz waves are being commercialized for industrial applications. However, in order to circumvent high absorption losses, engineers have traditionally had to rely on bulky and expensive fibers. Sub-wavelength size polymer suspended core fibers may offer a low-loss solution. Rainbows provide beautiful colored curved projections of light. Persuading light to do the same thing on a metal surface is not so simple. An international team has shown that so-called airy beams, non-spreading accelerating wave packets, might be a way forward, providing a tool for studying non-diffracting waves on a chip. Another group explored whether plasmons could be tuned to graphene, unlocking new potential in this extraordinary material. This year, researchers finally observed the so-called peregrine soliton, an analytic solution to the nonlinear Schrödinger equation. Only recently has it become clear that solitons can be observed, controlled, and used in optics technology. This might allow us to generate sources in new spectral regions and to provide increased signal propagation capability. "3D projection systems can trace their origins to 1950s cinema and the holograms that first appeared in the early 1970s. Researchers from Arizona and California showed how holography is being used to create high-resolution displays. Another group worked on an algorithm for creating 3D television with full parallax, no glasses required. Research in interferometry showed that single photons carry all the intricacies of complex spatial modes, including helical wavefronts and optical vortices. A German team demonstrated how tailored light fields are being used as a new approach for creating optical traps. If infrared detection could be performed on an uncooled GaN detector, it might open a way to producing all optical switching devices, operating solely on nonlinear absorption, according to a team of US researchers. Although fluorescent microscopy is transforming biological research and diagnosis, the chemical labels that are used are a limitation. As a Harvard team found, a clever reworking of stimulated Raman scattering could provide unique spectral signatures that can be used to study ex vivo cell chemistry. Colloidal liquid suspensions of magnetic nanoparticles have a wide range of applications, from spacecraft attitude control to cancer diagnosis. When inserted into microstructured optical fibers, these so-called ferrofluids allow for the tuning of Bragg gratings and constitute a versatile platform for developing novel optofluidic sensing and actuating devices. "2011 was a year of considerable achievements for optics research. 2012 should be a year to look forward to.